Okay, everyone. So this is part 2 of plotting an epicenter, or how do we locate an earthquake's epicenter. And for this activity, you are going to need your notes pack, and we are going to start working on page 31. So open up to page 31. You're going to need a nice sharp pencil, either mechanical or wooden. You are going to need ESRT page 11. You are going to need a scrap piece of paper. Hopefully you still have Mr. Green Sheet. All right, hopefully you still have Mr. Green Sheet. If you don't, just get any old piece of scrap paper, any color whatsoever. And you're also going to need a calculator, and I'm just using my phone, so you might need a calculator too. Okay, so what we're going to do is we're going to take our first shot at reading seismograms and using our P&S wavetable skills. Okay, so what we have here is, this is called Finding Epicenters 1. And what we have here are 3 seismograms from 3 seismic stations. One seismic station is located in New York, another one's in Louisville, let's assume Kentucky, and another one's in Pittsburgh. All of these stations recorded one earthquake's data. So all of this data is from one earthquake, a single earthquake. Okay, so there's a seismologist in New York, seismologist in Louisville, and seismologist in Pittsburgh. And they're going to share their data. All right. So what we first have to do is we first have to get the arrival or clock times in hours, minutes, and seconds of the P wave and S wave at each station. So we're starting easy. We're starting baby steps. So here we have, they labeled the P wave arrival and the S wave arrival at each station. And we draw lines straight down when they arrive. And remember that these are minutes. So this is 2:47:00 seconds. This is 2:48:00 seconds. So remember that there are how many seconds in between? There's 60 seconds. So sometimes we're going to have to estimate, like if we're right here, it's going to be 30 seconds. If we're right here, it would be 20 seconds. We're never going to get more exact than that. You might want to do a 5, but your answers for seconds are usually going to end in 0, okay? So what do we think for the first P wave arrival? Exactly 2:47? I agree. So it arrived at 2:47:00 seconds. Remember, these are clock times, so you need all 3, all right? The S wave, what do we think? Exactly on 2:53? I agree. So 2:53:00. Okay, let's go to Louisville. P wave arrived exactly at what? 2:45. 2:45:00. S wave arrived at exactly what? 2:49:0 seconds. Okay. Pittsburgh. P wave arrived at, yep, I agree, exactly 2:44:00. And this is the only one that's not on exactly on a minute. So what do we think? But somewhere between 2:47 and 2:48. Closer to who? Is it exactly halfway, or is it skewed to one side? It's about a third, isn't it? So if it's about a third of a minute, a third of 60 seconds is 20 seconds. So 2:47 and 20 seconds. Okay, so now we know the P arrival and the S arrival for all 3 stations. Without even going any further, who's closest? Who's closest if this is the same earthquake? Which station's closest to? Yep, Pittsburgh. Look at that. It arrived at Pittsburgh the earliest, didn't it? And New York the latest. So we know who's closest, who's furthest, and who is in between without doing a darn thing, okay? That's what we know. All right. So remember the difference in arrival time is always the S arrival, write this down, minus the P arrival. Always, always, always. All right, so 2:53:00 minus 2:47, that is a difference of exactly 6 minutes. 2:49 minus 2:45 is a difference of, let's see, 9 minus 5, it's a difference of 4 minutes. And here, 2:47:20 minus 2:44, well, 20 minus 0 is 20. 47 minus 44 is 3 minutes, 20 seconds. So now we have further evidence that this station is closest, because this is where the Porsche beat the Subaru by the slimmest margin. And up here, this is furthest because this is where the Subaru got the worst butt kicking. You with me? This is ringing a bell? Hopefully so. So now what we need to do is we need to find distance to epicenter. So for the first station, what are we going to mark off? We need to know the distance to epicenter when the butt kicking was 6 minutes, or when the lag time was 6 minutes. So we take our green sheet, we put it on our PNS wavetable, put it to the right so you can see the little tick marks. And what are we going to mark off, everyone? We're going to mark off 6 minutes. 6 minutes. Okay? And what are we going to do? We're going to slide it up. Up. And, wait a minute. Nope, 6 minutes is too short. I'm going to go down a line. Let's see. Oh, that looks pretty good right there. Yes? So my 0 tick mark is on the P line, my 6 minute tick mark is on the S line, and my paper is vertical. My paper's vertical. So now what do? I reach straight down. 4,400 kilometers. That is my distance to epicenter. Again, when the lag time is 6 minutes, my distance to epicenter is 4,400 kilometers. 4,400 kilometers. Whoops. Okay. So now I've got to do 4 minutes. So to make myself not get crazy and visually, you know, messed up, I'm going to erase my 6. Okay. So now I'm going to mark off 4 minutes. So I bring that 0. I line up that 0 nicey nice, right? Accuracy and precision is key. Mark off the 4. Mark off that 4. Slide it up, slide it up, slide it up, up. Let's see what's going on there. Well, that's pretty good. I don't know. I'm gonna go up 1. No, that's no good. I'm gonna go down 1. Nope, the 4 is too tall. Looks like that's my best fit right there. It's like Goldilocks. This one's too short. That one's too tall. This one is just right. So now I go straight down, and I'm right here. 2,200, 2,400. I am 2,600 kilometers from the epicenter when my lag time is 4 minutes. 2,600 kilometers. Okay, last one. I'm going to erase the 4 again so my vision is not obscured by other marks. And I'm going to mark off 3 minutes, 20 seconds. So we'll put my 0. Real nice. I'm going to mark off 3 minutes, 20 seconds. Okay. And I slide this up until I get a good fit between the two. That looks a little too short. I don't know. Hold on. No, that's too short. That looks pretty good. I'm going to go in between, though. I might be more accurate. Oh, that's nice right there. Oh, in between the 2 lines. Everyone see that? That's nice. Okay, what do we got? Not 2,000, not 2,200. In between, 2,100 kilometers. 2,100 kilometers. That's my those are my distances to epicenter. Now, as you saw in the last video, I would take these distances and swing the arcs on a map and find out where the epicenter is. But that's not what we're doing right now. Okay, we're gonna get this math down. Turn the page. We're gonna get this math down. We're gonna become so proficient at this and speedy at this that when it comes time to swing an arc, that's going to be the easiest part. Okay? All right, so this is finding epicenters 2. This is more practice. We have added 2 columns. We've added the P wave travel time and the time of origin, or the earthquake origin time. All right, so what we have here is 2 separate earthquakes. 2 separate earthquakes. This is earthquake 1. And this is earthquake 2. All right. We're going to do one together. And then for homework, you're going to do this one, and you're going to do finding epicenters 3. And you're also going to do just this page. Okay, just this page right here, this bottom here, 34. Obviously, you're not going to do this. I'm going to show you how to do this tomorrow. Okay. And you're just going to do the top here, just the top. You're not going to do this bottom part because you can't do this until you do this. Okay. But I'm going to show you how to do those tomorrow. Okay. So what we need to do is we need to get the differences. So they gave us we're not reading a seismogram right now. They give us the PNS wave arrivals on a silver platter. So all we're doing is subtraction. Okay. So difference in arrival time is always S arrival. Write this down. Minus P arrival. 536.40 minus 533.40. That's a difference of 3 minutes. 548.45 minus 5, 40, 25. 45 minus 25 is 20 seconds. 48 minus 40 is 8. 8 minutes, 20 seconds. 543, 30 minus 537, 30. Okay, 30 minus 30 is 0 seconds. And 43 minus 37 is 6 minutes. Okay. We're going to use our green sheet method to find distance to epicenter. Okay, so right now we should be getting a little bit faster at this. We're going to mark off 3 minutes. Mark off 3 minutes. Okay, mark off 3. Slide it up. That's looking pretty good. 1,800 kilometers. Should be 1,800 kilometers. Okay. Now we got to mark off 820. That's pretty far. That's a big gap. Okay, so put the 0 down nice and accurate. 8 minutes, 20 seconds. Right there. Okay. And I'm going to slide green sheet up. Ooh, right there. Let's see. That's a little... This mark looks a little too high, so I'm going to try the next one. That's looking a little too low. Maybe in between. Yeah, that looks pretty good. Right in between. Okay, so that mark is right on there, and that mark is right on there, so I'm going to go swing down. Let's see. Looks like 6,900, because it's between 68 and 7,000, so 6,900. And then the last one is 6 minutes. Okay, so take my sheet. Mark off 6 minutes. This sounds familiar. I think it was on the last page, wasn't it? Let's see if we get the same answer. Yeah, 4,400. Actually, 4,500 or 4,400 would be good. Okay, so I'll say 4,400. Is that what we got on the last page? Yep, 4,400. See that? Okay. So now we're going to take it a step further. Oh, so for this, your memory aid to do the distance to epicenter is your green sheet method. All right. Now that we know the distances to epicenter, now we can determine the P wave travel time. So these questions were, hey, if the Porsche arrived at your, if this race started at 2 o'clock and the Porsche arrived at your, and the Porsche went 1,800 kilometers to get to you, what time did it arrive at your door? Ding dong, meep meep, okay? So that's what we're doing now. And so what we're doing now is using this graph in another way. So I'm going to move this over, okay? So the P wave travel time in minutes and seconds. Okay, when the race is 1,800 kilometers long, you go up until you see the P line and you go across, and the P travel time was 3 minutes, 40 seconds. It took the P wave 3 minutes, 40 seconds to travel that distance. When your epicenter distance is 6,900 kilometers, okay, so we found this was 6,900, we go up, 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 up until we hit the P line. Right there, it's on a line and we go across. 10 minutes, 20 seconds. 10 minutes, 20 seconds. All right, and finally, when your distance to epicenter is 4,400 kilometers, 4,400, you go up, 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 up until you hit the P line. Looks like it's kind of in between two lines here. You go across. 7 minutes, 30 seconds. 7 minutes, 30 seconds. Okay, so this is just a straight up, you're going to enter the graph. Enter graph from x-axis. Okay, that should be your memory aid as to how to find this out. Now, this is the earthquake origin time. The time of origin, what we call the earthquake origin time. This is what time the race started. Do you remember? Okay, so what time did the race start when it took the Porsche this long to get to you and blah, 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 blah. So how do we do this? This is always either P arrival minus P travel or S arrival minus S travel. We don't have S travel. So what we're going to do here, this is P arrival minus, write this down, minus P travel. PARR minus P trav, okay? So this is where we might need to show our work for this. Okay, so P arrival is 533.40, 533.40 minus 340. Well, that's pretty easy, right? So this is 530. So I'm saying that based on this seismic station, the earthquake occurred at 530. All right. Now the next one is P arrival of 540.25 minus 1020. So 540.25 minus 1020. Well, 25 minus 20 is 05, and 40 minus 10 is 30, and 5. So 530.05. Wow, does that make sense? Sure it does, because we're talking about one single earthquake, and yeah, it should happen at the same time. Thank you very much. Now, is this an acceptable difference of time? Yeah, it is. I'm using this, I'm using this, and I'm using this. That's pretty good if you ask me. Not to break my arm and pat myself on the back, but whatevs. Okay, so the last one. We have P arrival of 537.30. 537.30 minus 730. 30 minus 30 is 0, 0. 37 minus 7 is 30, and 5. Oh, snap. Look what we did, folks. We know we did our work correctly. Yeah. Okay, how do we know? Because our earthquake origin times are all approximately the same time, and yeah, they should be. So if you get an earthquake origin time that goes rogue, if you have an earthquake origin time that's like way off, what do you know? You know you have to go back and check all this stuff. That's what you know. Your earthquake origin time. These should be like plus or minus like 30 seconds. Occasionally, you're going to get plus or minus like 1 minute. All right. These should be relatively close to one another when you're answering all these questions. Okay. So again, I want you to analyze this earthquake. I want you to answer these questions. I want you to analyze these two earthquakes. Remember, even though these are the same seismograph stations, these are two separate earthquakes. And then on this page, this is just one earthquake, but this is good data. We have 4 seismic stations. We have more than 3. We have 4. Good is better. Less than 3 is not good. All right. And then on this page, you have 3 different earthquakes. On this page, they're giving you the difference in arrival times. All you're doing is getting distance to epicenter. That's it. This page is easy peasy. I just want you to get your distances to epicenters for those 3 earthquakes. So earthquake 1, 2, and 3. Again, you can't do down here. I'm going to show you how to actually sweep the curves tomorrow. Preview. We're going to be using compasses. Whoop, whoop. See you next time, guys.